Okay, good. So we're going to look at a few more quadratic applications and maybe go from there. Well, maybe not necessarily quadratic applications, but I guess from your book's perspective, applications that involve quadratic type problems. How many of you know the Pythagorean theorem? That's one you should all know, right? For right triangles, what is it? A squared plus b squared equals c squared, correct? So we're going to kind of use that, but in the same way that when we solved, say, interest problems and distance problems, we used the formulas, but we didn't just plug in P and R and T and get an answer because that's stupid. We kind of use those to solve more complex problems, right? So say we have this. I don't know. I lean a ladder against my house. The distance from the base of the ladder to the base of my house is 2 feet more than twice the distance to where the top of the ladder hits my house. How long is the ladder? I lean a ladder against my house. The distance from the base of the ladder to the base of my house is 2 feet more than twice the distance to where the top of the ladder hits my house. How long is the ladder? So first off, draw a picture, correct? Anytime you're doing these geometric ones, even if you figure you know exactly what's going on, draw a picture just to help you out. So in this case, what do I have? That's the ground, that's my house. Not much in the way of artwork, whatever. Then we have the ladder leaning against my house, like this. Now what do we do? Oh, we might not actually be able to solve this one just yet in the semester. Well, yeah, we'll say this. We will alter this slightly just to make it somewhat easier before we move on to other challenging type ones. How long is the ladder if the length of the ladder is 3 feet more than 2 times the distance of the ladder from the base of my house? So yes, just to read it one more time. I lean a ladder against my house. The distance from the base of the ladder to the base of my house is 2 feet more than twice the distance to where the top of the ladder hits my house. How long is the ladder if the length of the ladder is 3 feet more than 2 times the distance of the ladder from the base of my house? We got it all? So what do? What are we looking for?
X.
What are we looking for? In this case, the length of the ladder, right? But we have three different quantities going on, correct? So, well, we said before, if you're looking for more than one quantity, and clearly we'll need all the quantities to solve this out, find the quantity that everything is compared to and let that be your x, and then kind of build your other variables from there, right? So let's see. The distance from the base of the ladder to the base of my house is 2 feet more than twice the distance to where the top of the ladder hits my house. How long is the ladder? If the length of the ladder is 3 feet more than 2 times the distance of the ladder from the base of my house. So it would appear that the distance here is compared to the distance there, and the distance here is compared to the distance there, right? So ultimately, everything is compared to this distance. Yes? So call that x, this distance right here. Then, what is that distance right there?
2x plus 2.
We're told the distance from the base of the ladder to the base of my house is 2 feet more than twice the distance to where the top of the ladder hits my house. So 2 feet more than twice x. Then what's this distance right here? Let's see. How long is the ladder? If the length of the ladder is 3 feet more than 2 times the distance here. So, take that distance there, 2 plus 2x, and it's 3 feet more than 2 times that. So 2 times that, plus 3. The next step is what? Once you have your variables set up, create an equation, correct? And in this case, what's my equation going to be? What equation am I going to use? Right here. That's a right angle, which means Pythagorean theorem, correct? So set it all up. And let's see, in this case, we should have room maybe right here. We get this side, x squared, plus this side, make sure to put it in parentheses, 2 plus 2x squared, equals that side, 3 plus 2 times 2 plus 2x squared. And then solve it all out. Do we want to work through the math to FOIL all that out, or are you all good? FOIL it all out? Or not even worth it? How many want me to FOIL it all out? Raise your hands. We got a couple of people. Okay, we'll at least start it. Right here, to start, distribute here. You'll get 2 times 2, which is 4, plus 2 times 2x, which is 4x. And then combine. 3 plus 4 is 7, so that's 7 plus 4x. Now FOIL everything out. So let's see, on the left, we get x squared plus here, all of you know that's perfect square, 2 plus 2x times 2 plus 2x. 2 times 2 is 4. 2 times 2x is 4x. 2x times 2 is 4x. 2x times 2x is 4x squared. Equals, and I'm going to run out of room on the video, so I'm just going to write it down here. Same thing, FOIL here. 7 times 7 is 49. 7 times 4x is 28x. 4x times 7 is 28x. 4x times 4x is 16x squared. And yes, that may look, rather long, but ultimately, we have a bunch of squares on here. It's a quadratic. So, how do you solve a quadratic? Set it equal to 0, right? Bring everything to one side. So in this case, just because the 16x squared is biggest, I'm going to bring everything to the right. So we'll get 16x squared minus x squared, which is 15, minus 4x squared, which is 11. So 11x squared. Then we get 28x plus 28x, which is 56x, minus 4x, which is 52, minus 4x, which is 48. So plus 48x. And then on this side, we have 49 minus 4, which is 45. Correct? Now, that's just a quadratic. Here, just to save time, you can all put it into the quadratic formula. We've done that multiple times, right? Put it into the quadratic formula, get your x. When I get my x, am I done? No. What do I do then?
Plug it in.
Yeah, because in this case, I'm actually looking for this right here. So get your x, plug it back in, and figure out the length of the ladder. Got it? Okay, good. I'm going to leave that one to you guys to solve because we've already solved multiple quadratics and I don't want to spend too much time on it. One more. Let's see. I go fly a kite. The distance from me to a spot directly below the kite is 20 feet more than the height of the kite. We'll word it that way, make it easier. The kite string is 100 feet long. How high is the kite? Okay. We're going to solve this in a second, but I'm going to stop the video. You guys here, see if you can draw a picture and set up the variables and set up the equation. I'll give you a minute. And same for you guys watching this on the online class. This is the end of this video. I'll set everything up at the beginning of the next one, but before you watch it, see if you can set it up on your own. Come up with the variables, draw a picture, come up with the equation, and then look at the next video and see if you were right, and we'll solve it all out.